Okay, I think we're live, Mike. Are you
Okay,
ready?
ready.
Okay. Home Assistant, Year of the Voice, Chapter 2. Let's do it.
Let's do it.
Haha! Hello. Awesome. Welcome, everybody. Welcome. Um, yeah, Home Assistant, Year of the Voice, Chapter 2. We're going to have a lot of cool stuff to talk about today. But let's do a quick introduction round just so that you know who's talking today. My name is Paulus Schoutse. I'm the founder of Home Assistant 10 years ago already, or 9.5, I would have to say. Yeah, and super stoked to be here today talking about voice.
And I'm Mike Hansen. I'm creator of Raspy, the private voice assistant toolkit, and a member of Nabukasa here, and the leader of the voice engineering.
All right. So today, Year of the Voice, we're going to start with a quick recap just to see like what is Year of the Voice. Chapter 2, obviously we had a chapter 1. We're just gonna take a quick look at like what happened, why we did it, and how it's going now. And then we're gonna go into all the good stuff that's coming today. Like I said, I'm super excited, and I believe that at the end of this hour, or more or less it'll take an hour, all of you will also be super excited about like the things that we are presenting. All right. So let me find my slide. Year of the Voice. So we're doing Year of the Voice with Home Assistant. And what does that mean? It means that we set ourselves the goal for 2023 that we want Home Assistant users to be able to control devices in their house using their own language at the end of the year. Now, this doesn't mean that we want to build a voice assistant where you can query like Wikipedia and ask those kind of things. No, we really wanted to limit to just, turn things on. What does this state? Turn things off. Of course, we want to do this in the languages that people use at home. Like Home Assistant itself already has 62 different languages it supports. And so we need to build a voice assistant that supports 62 languages. To kind of kickstart the project for Home Assistant, we've hired Mike Hansen, also on this call, of course, today, because with his work with Raspberry, one of the things that was very always impressed us very much, is that where most open source projects, they focus on like their main language being like English. There's some German projects, but there's a lot of underrepresented languages inside the open source voice community. And we felt that, we wanted to give them a platform. And Mike was actually doing that with Raspberry. So his work has always been like, how can we get more and more voices, available for text to speech and speech to text? And so that was a great fit. Home Assistant, we want to support a lot of languages. Mike is passionate about supporting a lot of languages.
Definitely.
So today we're here and we're going to talk about like voice. Now, it is important to note that when we are doing these kind of, milestones for today's chapter 2, what we're announcing is not the finished product, where it's really just like an update, a progress update. Where are we at? And the things that we're releasing today, because we are obviously releasing some new things, are really building blocks. So we want to build the building blocks, the tools that together with the community, we can expand it to a lot of more different languages, and not just the few languages that we've tested out or like the few sentences. We'll get there also when we see like the chapter 1 update, right? Like we in January released chapter 1, we did intent recognition. It was small. Nowadays it's a lot bigger. All right. So quick note, because we get this question a lot, is like, how do you do all this? Like Home Assistant is a big project, second most active contributed project on GitHub last year. We have 13,500 people contributing. It's a huge organization. We ship a lot of stuff. We build a lot of stuff. How does it work? Now, it works because 5 years ago, I founded a company. It's called Nabukasa, and Nabukasa exists to support the Home Assistant project. It does so by creating a cloud service called Home Assistant Cloud. Because while Home Assistant runs at home, it means that while you're not at home, you cannot always connect to your Home Assistant instance. So with Home Assistant Cloud, we can offer an end-to-end encrypted remote connection so you can always access your Home Assistant instance. Now, actually, there are some extra services like speech to text, text to speech that we're also getting into, which is also included in the Home Assistant Cloud subscription. Now, Nabucasa has no investors, and all the money that is being raised with Home Assistant Cloud goes back into the investment and building out Home Assistant, running Home Assistant, and adjacent projects. So we're also building ESP Home, ESP Web Tools, Improv Wi-Fi provisioning standard. We support the BT Home, Bluetooth low energy sensor standard, and a lot of other different projects. And because we have no investors, our only sole purpose is to support the Home Assistant community, because that are the people in the end that are paying our bills. So that's how we roll. That's why we're sitting here today. It's thanks to many of you that are watching today that are chipping in to support the development for us to build all this cool stuff. So that's also why this is a big important day for us, because this is where we're delivering, right, on the promise of giving cool stuff. And I think that we can do it.
Yeah, this is why I got to do this full time, right?
Right.
Thanks to the subscribers.
Last thing I want to just mention, where a lot of times you see like projects on YouTube, whatever, people are doing really cool stuff, and then you try to do it at home, and like it's super difficult. You need to go through a lot of technical steps. We have today, just as we always do, we focus on showing projects that you can replicate with very minimal effort today. So we'll also go a bit into that kind of details, because in the end, we don't want to just be able that Home Assistant is capable of doing cool stuff. We want everybody to be able to use Home Assistant to do the same cool stuff. All right, Mike, up to you.
All right. So these are the basic building blocks of a voice assistant. You have a user speaking to some device. Then you have a speech-to-text system that's going to transcribe it into text, take that text, figure out what the user wants to do, and execute it, and then provide some kind of response. And at the end, sometimes that response could be a beep or a confirmation, or it could be a full text-to-speech response where it actually talks back to you. All right, so let's go forward. All right. Like this is one of the more difficult portions of this whole process, is figuring out what the user said. And while this is I'd say a solved problem as far as data centers and clouds are concerned, locally, this is still a hard problem. Now, even more difficult, surprisingly, is if you don't have some kind of physical interaction with a device. If you just need to wake it up with a wake word, like hey, name, I won't say. That turns out to be a very hard problem, mainly because the moment you have even the tiniest false positive rate, where it wakes up without you intending it, then it could do all sorts of weird things, right? It could wake up with the TV and start opening your garage door or something. You don't want that. So that's a very hard problem. That is not going to be what we're talking about today. Instead, we'll talk about that later. So for chapter 1, what we did for the first release is we focused, we were working our way backwards. So we wanted to start with something where we could have a deliverable that actually worked and was usable. So we focused on the text intent recognition portion. So you're able to open the assist dialog, type in some text, have it execute, and have it respond back to you with text. And I think we did a great job on that, thanks to our contributors. And we got it to work through various pieces of hardware, like the Android Watch, through Siri. So Paulus had that great demo where you could actually forward Siri, Google through Siri and whatnot. It's kind of cool. And so at the end of chapter 1, we supported 22 languages, again, thanks to our contributors and our language leaders who contributed those translations. And now, so a little bit of an update for those text intents. We're up from 22 languages to 45 languages. So we're closing in on the 62 that Home Assistant currently supports. And this is thanks to 165 contributors, which is just incredible. And there's more coming every day. We hope if people see that their native languages aren't in there yet, to reach out and contribute some translations. All right, so that was our first release in chapter 1. And in chapter 2, now we're focusing on just the hard problem. And this is speech to text, which is fairly difficult. Text to speech, which is a little less difficult, but still tough. So we're going from text to audio and back. And we will save the hot word detection, wake word detection stuff for a later chapter. for now, we're going to be doing audio capture manually to make sure it's always working. So we want something that's usable for everyone today. And part of this is we can actually get to reuse components that are already in Home Assistant, which is awesome. So there are already speech-to-text, conversation, and text-to-speech components in Home Assistant. And the speech-to-text and text-to-speech ones are automatically part of Home Assistant Cloud too. So this is something that people will be able to use right away. And so what we've done is we've taken all of these different building blocks of a voice assistant, and we've kind of formalized it into something called a pipeline. So what you saw, with that flow through the different services, this is now something that you're going to be able to create and customize yourself, and you're going to be able to pick different services and stuff to fulfill those different pieces. And we'll talk more about the user interface portion and all that later. But for now, I think everything around this whole chapter is focused on this abstraction called the pipeline, where you take audio in and usually get audio out.
Yeah, and this voice assistant infrastructure, so to speak, is going to be the foundation of everything we're going to talk about today. So we're going to show you different speech-to-text, text-to-speech engines. We're going to show pieces of technology that will interact with the Assist pipeline from external, outside of Home Assistant, from inside of Home Assistant. And of course, there is going to be an API. So if people want to have their own projects built on top of like voice assistant infrastructure and Home Assistant, that's all possible. So the first thing we want to show today, and Mike already kind of mentioned this, is like Home Assistant Cloud includes speech-to-text, text-to-speech. And so the first voice assistant that is working out of the box is the voice assistant powered by Home Assistant Cloud. So with Home Assistant Cloud, there's speech-to-text, text-to-speech APIs powered by Azure Cognitive Services. This is the Microsoft Cloud. These are high-quality voices. Azure supports over 130 different languages and dialects. So there's not just Spanish, for example, but there's Peruvian Spanish and like a lot of different variants. English, there's like Irish English and Indian English and Kenyan English, etc. And what is great is that because speech-to-text, text-to-speech models are very, very heavy to run, if you have Home Assistant Cloud, you will not need any extra hardware or software, and you can actually start using voice assistants today. Like, you will install the beta, you will install the release coming out next Wednesday, and you're good to go. So I wanted to show you a quick demo of how this works. This is also going to be directly showing the first bits of UI improvement that we did. So this is the Assist dialog. It looks still very similar as last release. There's a new drop down where you can pick your assistant, because you can create as many assistants as you want. And also because Home Assistant Cloud supports different languages, you can also say, hey, I want to have an English one, I want to have a Dutch one. I'm not going to go this time and speak all those different languages. I will show like two different ones. I have an English and a Dutch one configured. So this microphone icon, when I speak to it, it will actually record my audio. It will send it to the speech-to-text through that I've configured in my pipeline. This is one with Home Assistant Cloud. The text will be processed. It will act upon it, create a response, and read it back to me. So let's give it a shot. It's demo time, so it's probably going to go wrong, but we'll see. Turn on the bed light.
Turned on light.
Whew, okay,
All right.
Good. Well, ta-da! Turn the bed light off.
Turned off light.
Now, of course, you can pick different languages, so I'm just going to show the Dutch one as well. Doe het bedlampje aan.
Aangezet.
So as you can see, you can easily switch different pipelines and, control your house through Assist. This is through Home Assistant Cloud. Let me just back the tab. And yeah, the people that are subscribed to Home Assistant Cloud, they will be ready to go when this release is dropped. And as you can see, it was really, really fast.
Mm-hmm.
Where the hardware in the cloud that is running and doing the speech-to-text, text-to-speech models are very powerful machines. And we're doing a smart thing that while you are speaking, to Home Assistant, Home Assistant is uploading it already directly. So the moment you're done speaking, the upload is basically done, and we can get the text right away and start processing on it. So clouds. I just want to do a quick. I think this is a slide from last time, and I just want to talk about like different types of clouds and why we are offering with Home Assistant Cloud like speech API. So the two types of clouds that are out there. The first one, and that's the one that we do not like, is the IoT cloud. These are cloud systems like Google or Amazon. Those are built to store your personal data in a way that they know that it's about your house. They know the state changes. They know when you turn on a light. And the revenue models on these things, because you are not paying for these clouds, is because they want to learn from your data, right? You buy a Google Assistant device once, you buy an Amazon Echo once, and after that, there's no ongoing cost. So someone has to pay for those clouds. They learn from your data. The other type of cloud is what a generic cloud, like a service cloud, where, for example, a text-to-speech API or a speech-to-text API, where we send it some input and we get some output, and it's a pay-as-you-use. There are strong data processing agreements tied to it. And these are, for example, provided by Azure, Google Cloud, Amazon Web Services, and also Home Assistant Cloud is part of this. We people that subscribe to Home Assistant Cloud, Nabu pays the bill for the Azure Cloud Services, and subscribers can use as much text-to-speech and speech-to-text what you want. Now, the third option is, of course, no cloud. And of course, if you've been around Home Assistant, there's two things that we can always guarantee is one, there's going to be options. You can pick, whatever suits your way of doing things. And the second, there will be a local option. So to kind of talk about that next is Mike.
Yes. So let me talk about the local options that you can start using today. The first is a speech-to-text service based on OpenAI's Whisper. So Whisper came out last September. OpenAI released that for free to everyone, and the open source community kind of took that and optimized it like crazy, and brought it down to something that could run pretty well on a small board or single board computer. So Whisper I'd say it has good support for about 10 languages. It technically can support 30, but the accuracy kind of drops off. And it has multiple sizes of models, so the large ones can get much more accurate and close to data center quality today. I would say that even the tiny models are data center quality of 10 years ago. And what you can do today now is there's a Home Assistant add-on called Whisper that you can pull down. You can run this on your Home Assistant server, even on a Raspberry Pi, although I'll say it's the response times, as you can see, are pretty large, about 6 to 7 seconds to transcribe a voice command. But something just a little more powerful, I have a little Lenovo ThinkCentre PC that has an Intel i5 in it, which isn't super modern. And there you can see it's about 3 times slower than the cloud, but still sub-second response time. So that comes back pretty quick. So that's the speech-to-text portion. So let's jump over. Now, text-to-speech, at least to date, there hasn't been something that's come out that's as great as Whisper that's free. So we went and created our own. I've been working on Piper here since last year, and so this is out now as a local fast text-to-speech system that's been optimized for the Raspberry Pi 4. So I'll show some performance stuff as numbers here, but you can go check out samples. You can pull in the add-on yourself and try it out. And out of the gate here, we have, I think it's 18 supported languages, with a focus trying to be not just on non-English languages, but on traditionally underrepresented languages. And all of this is coming from open data sets that people have contributed, some from reading audiobooks. Others, I've been working with some various nonprofits to try and train models for them, with the caveat, this also goes out for free for everybody. And we'd like, if you see the email address, if you're interested, you don't see your voice, your language supported, or your dialect specifically, we'd love to talk to you and see about getting a voice data set that can be released into the public domain.
But Mike, what would you say, how much hours of voice would you need? Or what are the requirements? Like if somebody is saying, oh, I think I'm interested, but we can't just accept any voice, right?
Yeah, so we need, it needs to be high quality audio, a good microphone. About 2 hours, 2 to 5 hours will get you a really good voice. Something like 24 hours will get you an incredible, incredible voice. But the important thing is that you're in a nice quiet environment with a good mic, because I've had it try to reproduce, it'll reproduce sounds like birds in the background, or kids playing, or the vacuum cleaner if you're not in a quiet environment. So you want to make sure that's really important. If somebody knows like a voice actor who also can use a recording booth, that's perfect.
Yeah.
I've been trying to work with some universities that actually have that over in like the Middle East and such.
Yeah, because we see that like the book reading voices are great because you have the text transcoded of like, what's in the voice. But when people read books, it's not like they're talking, right? It's a different they have a different tone of voice. So it would be great if we can like start gathering some more voices of more, meant for speech, really.
Yeah, and another problem with the book voices is people almost never say single words in isolation. So when it says, and the voice needs to respond with yes, no, it's actually doesn't sound as good. So yeah, we have data set or text data sets that we've developed that would be great for this if people would record.
So before we go to the demo, because obviously we're going to demo this right now, I just, Mike, can you tell us a story behind the Nepali voice?
Yeah, sure. So there I'm working with a guy who works with some rural schools in Nepal, and they don't have great internet connections, so they can't use something like the Azure text-to-speech voices, and so they want to have books that are read to their kids, there, so the kids can go through and have it read to them. And so we've worked with them to try and train some voices so they can do that offline. And that's I think that's the great use case of Piper, when you want to have something that still sounds great, but it also works offline.
Exactly. All right.
Yeah, and just some performance numbers on the Raspberry Pi 4, which has been the target. The voices come in various qualities. I don't have every quality for every voice yet. I'm training these all on machines sitting around me. But the low quality it's about a 1-to-2 ratio, so 1 second of CPU time to get 2 seconds of audio, which is still pretty good for a Raspberry Pi. And you can see as you step up to the high quality, then you get actually flips the other way, so it takes twice as long. Medium, I'd say, works great for if you have headphones on. It sounds good. If you have a lower quality speaker, though, save the extra CPU cycles and just use the low quality voices.
Yeah. And this is great because these are the speeds on a Raspberry Pi, right? Not on the i5, as we saw that Whisper kind of needs to perform well. That Piper will actually work really well. And I think there's two extra things I would like to mention here is one, Home Assistant is very, very aggressive caching. So if you're going to play the same voice, same language, the same text for the second time, the data is already on disk. We're not going to go back to Piper and ask it to generate again. We will actually reuse the same sample or the same output of last time. So with our voice assistant right now, we don't include the names of when like a light was turned on, for example. It's just like, sure, I turned it on. Well, the next time we're going to render it turned on, it's going to be 0 seconds. It's already there. It's going to be instantly done. The other thing that is really cool here is that, text-to-speech is, of course, great for a voice assistant because it needs to read the responses to you. However, you can use text-to-speech for a lot of things, right? You can do it for announcement in your house, like the laundry is done, please empty the dishwasher. You could maybe notify your kids, dinner is ready. All these kind of things that are used to rely on different APIs. You will now with Piper be able to do this also in your own language.
Every time I go to the airport here in Iowa, they have it must be from 15 years ago, they did a text-to-speech system on the announcements, and it sounds awful. And I want to find whoever runs that system and say, look, just use Piper, it's free.
That reminds me, we should be able to just also create voices of like announcements from airports and just reproduce
Oh, yeah.
All right. Who wants to see demo?
Anybody? Yeah, I think so.
All right.
All right.
You have cloud selected, by the way, pipeline.
I do. I was going to, yeah. So same assist dialog, and I've got two other pipelines here that I'm going to talk about. This one is running on the i5, the little ThinkCentre PC. So this is going to be entirely local. And what I have a plant light and LED strip, yeah. Turn on plant light.
Turned on light.
So you can see that came back pretty quickly. Turn off plant light.
Turned off light.
And I made sure to clear my text-to-speech cache as well. So this was all happening in real time. Now you can see how this changes with the Raspberry Pi. So this is Whisper going in, Piper going out.
Please bear with us.
Yes, please bear with us. Turn on plant light. Oh,
Sorry, I couldn't understand that.
that's another good point. So the tiniest compressed model is what I'm running on the Raspberry Pi, and it has the lowest accuracy. And so with the i5 and above, you can actually run some of the higher accuracy models. But anyway, I
We'll
won't
do it again.
I'll do
This
it
was
one
not
more.
on purpose. Like all our previous demos went actually pretty well. So let's try it again, Mike.
All right. Turn on the plant light.
Turned on light.
I did realize too that plant light is I pronounced that pretty poorly. So I don't know what a plate light is. Maybe that is a thing.
I've never heard of it.
Yeah. All right. So those are the two demos. Let me switch tabs here so I can show you how this is all coming together. You see that okay? All right.
Yeah.
So this is over on the i5. I have the two new add-ons installed. So here's the Whisper add-on. And if you install this and go into the documentation, you can dig into your heart's content, all the technical details here. But this is the default model, which is only 43 megs. This is just incredible that actually works in such a small amount of bits.
Insane.
And that's uncompressed. It ends up being around 200 megs. And so you can switch models, and there's a couple more options to try and increase your accuracy at the cost of speed. So if you have the hardware, you could run one of these huge models and get near data center quality. And what happens is when you switch models and restart the add-on, it'll download them dynamically for you. So they're not all don't need to be included. And make sure absolutely to pick your language here if you want to do something non-English, because Whisper really needs to know that language up front for speed.
Yeah. The original Whisper model can do we'll figure out the speech along the way, but it's just not. It's a lot slower. The auto setting.
There's
So-
an auto setting, but it is I think it's like 5 times slower in my tests. All right, so Piper is the other add-on, and here we have a nice list of all the voices. I will go into showing some samples here, and in configuration, you can pick your voice. It'll download it dynamically, and then there's a few options to play with. You can change the speaking speed, as well as some options to change kind of how variable the speech is, if you want it more or less robotic kind of thing.
Yeah.
Let me
Hey,
jump
Mike,
over.
just before you quickly continue, I see a question coming in. What is the CPU usage when these two add-ons are idle?
Idle, it should be effectively 0. I've never noticed any CPU usage. Here's a little RAM on here. So this is sitting at 100 megs for Piper on the i5. Let's go look at Whisper. Yeah, that's only sitting at 100. So at idle, they're not using anything until we'll talk about how, but until Home Assistant contacts the add-ons, they should sit there doing nothing.
And that's, like I said before, text-to-speech will be rarely used, right? Because we're caching so aggressively.
Yeah, you'll be able to come in here. You can check your logs too if you want to see if Piper actually got hit or not, or it went through the cache. But
yeah.
So let me switch over. You can go here now if you want to check out the various samples. So we have
just gonna quickly
sure.
all the things we're showing today. We're gonna publish a blog post with all these links, right? So you don't have to keep track of it right now of all these links you want to go to. The blog post will go up after we're done with the stream. It has a whole overview, summary of everything we're going over today, including the sample link and all that stuff. So
right.
Oh, and one last note. Sorry, Mike.
Okay.
Is everything that you see today is available in the beta that is live right now of the 2023.5 release, which will be released next Wednesday.
Someone asked, can we record voices with Piper and play it on an Alexa or Google device? If they play like MP3s and stuff, yeah. So you
So
can
yeah, Google Home has the Chromecast protocol, and so Google you can just send audio to, and so it can play. For Amazon, you cannot. There is some hack that's some custom component, but it keeps breaking all the time, so I wouldn't recommend it.
Yeah, so here in Home Assistant, once you have this installed, these are my two different i5 and whatever, and the Raspberry Pi, but you can just come in here and have it say something.
Hello, Michael Hansen. You can play any text on any supported media player.
And that will put it in the cache of Home Assistant, so you have a recording there.
And actually, on this page in the bottom right browser, you can just pick like your destination, right? So
Yeah. So this is where you could announce to the kids that it's it's dinner time.
yes.
I like to do that with my kids. Okay. I'll show just a couple of voices. So like I said, there's 18 languages and then a few different dialects for at least for English right now. We're trying to I need to split out let's see, the Dutch has actually Flemish and non-Flemish dialects. But on the English side, I'm going to show Paulus's favorite voice. So he really likes Ryan.
I'll do Ryan Medium because then it's
Yes.
like at the bottom.
There we go. So here's Ryan Medium. These are all reading the first paragraph of the Wikipedia article on Rainbow.
Whoa. Okay. Mike just crashed out. We'll be waiting for him to come back, but in the meanwhile, I will just get the Piper things sharing. Let's see.
We run over a time limit or something?
You crashed, Mike.
I just crashed.
So I was. Do you want me to share the samples? I have it open now.
Yeah, sure.
All right. So we're going to play my favorite voice, Ryan. So Ryan Medium, just because high, you probably are not going to run the high model. Medium just sounds a little bit better than low. So just a sample text that is going to be read for everybody, and then yeah.
A rainbow is a meteorological phenomenon that is caused by reflection, refraction, and dispersion of light in water droplets, resulting in a spectrum of light appearing in the sky. It takes the form of a multicolored circular arc. Rainbows caused by sunlight always appear in the section of sky directly opposite the sun.
I heard the feedback on that.
Good, right?
That sounds really good. There's some feedback, but and do you want to
I mean,
play?
there's some feedback. It might actually be my speakers and microphone setup here.
Yeah, I think it's that. But I think one of the favorite voices people like is the Libra TTS. This is based on people reading books, and this one actually has 904 different speakers inside. People describe speaker number 0 as bored undergrad.
So it's the same. It's the same sample text, right? So I'm going to do one sentence. I'm not going to do the whole sample this time.
That's fine.
A rainbow is a meteorological phenomenon that is caused by reflection, refraction, and dispersion of light in water droplets, resulting in a spectrum of light appearing in the sky.
I think it sounds pretty good.
It sounds very good.
I do see
And
that.
then you don't see the drop down, but there's this drop down contains 904 different entries because this model can actually generate 904 different voices. I can actually I'll do a quick demo of like another voice.
A rainbow is a meteorological phenomenon that
This
is
guy.
caused by reflection, refraction.
So the quality goes down as the speaker number goes up.
Yeah, they've been ordered by how many samples were available in the data set, which is huge for number 0 and almost none for speaker 903. So there you go. And you can try these voices out with the Piper add-on, or you can quickly go through the samples and figure out which one you want so you don't have to download each one to try it.
All right, back to the slides. Let's
Yes.
see.
So we talked about the different add-ons. We didn't really talk about how the other piece on the Home Assistant side, and that's where the Wyoming integration comes in. Wyoming is the state I'm from, so I named this after that. This is actually a cool collaboration here with Raspberry version 3 that's going to be coming out later this year. The thing is, there's a lot of standard ways that people write voice services, and this Wyoming protocol that I've developed tries to capture those kind of common conventions. so that it makes it really easy for somebody to add a new voice service. For example, most text-to-speech systems, open source ones, take text in and produce a wave audio out. So there's no reason to have a different protocol for every single one when they all do the same thing, basically. Sometimes they take in a voice, right, a name. So that's what the Wyoming protocol does, is it provides a standard set of tiny little, very focused messages so that it kind of minimizes how much somebody has to implement to create a new voice service. And the cool thing is then somebody who's doing research, maybe they have come up with a new speech-to-text model or new text-to-speech. They could plug this in with just implement a couple messages, and it can join the assist as the full stack, right? So it can be, they only have to do one piece and they can get the benefit for everything.
Yeah, and I think that the overarching goal, what we're trying to do with Wyoming, is that we kind of want to kickstart a open source voice assistant community. So Home Assistant is adopting this protocol, Raspberry 3 is adopting this protocol, and if more and more models are going to be exposed over Wyoming, which they can do as many different ways at APIs, but if they add a Wyoming integration, it will work with both Home Assistant and with Raspberry. And if there's other open source voice assistant projects out there, they could also benefit from our work if they adopt Wyoming. And so in the end, we just want really people to be able to share their work, right? It needs to be like somebody comes up with a good voice, somebody comes up with a good speech-to-text model. Like, let's throw it in, let's play with it and see how it comes together in the full stack.
And as you saw already with Raspberry Pi and everything, it doesn't have to run on your local machine. So you can have your Home Assistant separate from another machine that might be running, the highest model of Whisper you can without it catching on fire.
Right. Yeah, I think that's actually one of the coolest things, that like maybe you have a big server, you can just turn it on, spin up a big model, generate all the text-to-speech output that you're going to need, and then like turn it back off again, and you're going to have it all in your cache.
So I have a question. Is there any alternative Whisper for speech-to-text on the Raspberry Pi 4 with better performance? Yes, and that's coming. The plan is, there are actually two plans that I'm going to be working on later. One of them is kind of, there's techniques to restrict Whisper down to just a fixed set of sentences. Those would be the ones in our intents repo. And if your only goal is to do smart home control, then we can get performance that way. There are also some older technologies that can have limited sets of sentences too, that run great on a Raspberry Pi 4 actually. So that's the plan, is to have these more limited options for people who, don't want to talk. Well, I won't spoil anything, but limited options for people who just want to do smart home control.
All right. Anything else before we wrap up Piper Whisper?
Not from me. Any other questions related?
I think the one question I've seen a few times, people are saying, "Can I train my own voice?"
Yes. So right now it still requires a GPU, a decent one, at least like a 3060 NVIDIA GPU, and some knowledge of getting like Docker or PyTorch spun up. But it is possible to, and what you do is you start with an existing voice already. I started with the Ryan. Actually, almost everything there was trained off of Ryan, because I have a lot of data for Ryan. And you do what's called fine tuning. You give it a handful of samples and you train it on those, and you can get a voice. We would not train a Yoda voice or others just for copyright, legal purposes. But I am happy to help people do that, and then they can share them. That would be great.
All right.
The most requested voice so far has been Paul Bettany.
Why? All right.
Me, Jarvis.
Now, for now, we've been really focusing on every demo so far has been using the assist dialog that we have upgraded, but we've actually upgraded the backend as well. So I'm going to share the tab. Boom, Home Assistant, settings. There's a new option in town, voice assistants. Now, if you're using Home Assistant Cloud, Amazon and Google will be in here, and you can manage your entities that are exposed. You can see which voice assistants are there. I'm not going to go too much talking about that right now. To learn more about that stuff, check out the Home Assistant release party that's happening next Wednesday. I just want to focus on this little box here. So as you can see, I have 3 different voice assistants configured right now. I have English Home Assistant, Dutch Home Assistant. And so let me just open one up. You can also note here, this one has a star. It's because it's the preferred one. So you always need to have a preferred voice assistant so that if a request comes in for a voice assistant, but they don't specify which voice assistant, it will take the preferred one. Now, there is a lot of config options, and we've tried to minimize it, went back and forth, and in the end, this is what it is. So let me just walk you through it. There's a name, but you're going to have to give a name to your voice assistant, and you need to give a main language. This is the language that will limit the languages that the others can speak in, or the dialect. So you can pick a lot of different languages. In this example, I'm doing English. Now, once you've picked English, the core or the brains of the whole voice assistant is always a conversation agent. It takes in the text, processes it into its intention, and then executes the intention. So we have different conversations agents, just like in chapter 1, we've already shown it. The other one is like OpenAI. There's also Google Assistant that can be used. And based on Home Assistant, you can pick like which English variant it supports. Now, the Home Assistant Intense only supports one type of English. We don't differentiate between different dialects. But when we get to speech to text, I am using Home Assistant Cloud. You can actually say the model performs better if you pick the language that you're going to speak, or the dialect. So if you're in America, you want to pick American English. But if you're in Australia, you want to pick Australian English. And I already mentioned that like we use Azure, and we have over 130 different languages and dialects. And it also means that there are a lot of different English variants. So, if you're in the Philippines, you have a different pronunciation than somebody in India. And so it's good to pick your dialect, so you're going to have the best performance. Now, similarly, when you pick text-to-speech to read the responses to you, pronunciation and these kind of things differ. So also there, we have a lot of different versions. I'm, again, showing English as an example. But not only can you pick the dialect, but then within each dialect, you can pick a voice. So for example, for American English, there's a lot of different voices that you can pick, and each voice sounds differently. So for example, this is Monica Neural. There's actually a try voice button, so you can try it out.
Hello. How can I assist?
So that's Monica Neural, but if I was like, now I want Roger, well, let's see how that sounds.
Hello. How can I assist?
Now you can change your pipeline settings to say, like, for example, I'm going to do French. Not that I know very well French, but, I know that we have 2 different French supported for the conversation agent. So there's French and there's Canadian French at the Home Assistant Intense support. The reason we support these different ones is because, and I'm 95% sure that this is the correct explanation, I've been told, the number system is differently. So the numbers need to map differently when you're a Canadian French speaker. Now, speech to text, it actually supports 4 different French. So you can also say I'm from Belgium, I'm a Canadian, or Swiss French. And output, same set of 4. And there's a lot of different voices available that you can pick the French voice that you like the best. Now, the other thing that I just close and open it again to reset so everything's back to English. There's a few buttons here. Delete, you can delete pipelines or assist voice assistants, but you cannot delete the one that is set as preferred. And this one is the really cool one, debug. We've built in extensive debugging because you're connecting so many different services, and you want to know what went wrong if something goes wrong. So by default, we keep a track of the last 10 interactions you've done with your voice assistant. So for every different voice assistant, I have the English, the Dutch, and the Mario one. It keeps track of every different interaction. And for each interaction, you can actually see how long did the speech to text take. It sounds long, 2.73 seconds, but this actually includes the time that I was speaking. So we still need to split this up to better represent where the time is going for comparison's sake. But yeah, right now it took me 2.73 seconds to say turn the bed light off, and the cloud speech to text to actually turn this into text. Now, natural language processing. Our Home Assistant intent system is super fast because we built it to run on a Raspberry Pi. So that was done in 0.01 seconds. Text to speech, it was cached 0 seconds. Boom. You can also replay the audio that was was being said.
Turned off light.
And if you really like details, you can see exactly all the events that were being passed on. This is really mainly for developers, but this really helps you if you're ever because until now we've talked into the voice Home Assistant UI, but if you're ever talking to an actual microphone or to a voice assistant microphone somewhere else and there is no feedback, you don't know what went wrong, and so you want to make sure that okay, what actually went wrong, and dig in. Now, besides debugging here, we also have an option to start a debug session right away. So you'll see everything printed as it happens. So for example, here, this is a input. I could just say, is the frame on? That's the one behind me there, the picture frame. Yes, it took 0.02 seconds to get the answer. It is not being played to me because when we do a text pipeline, we're only interested in text in, text out. Now, we also have a download button, so when you reproduce your issue, you can actually send it over to the Home Assistant team. For example, you're missing, if maybe you're saying a command and it was correctly transcribed from speech to text, but the Home Assistant system didn't understand it, it would be great to tell us so that we can actually improve the system. Now, we also have the audio pipeline, so I'm going to show that one as well. Turn the frame off.
Turned off light.
Turn the frame on.
Turned on light.
So what is very interesting here is that I was having a conversation, and so it kept repeating itself and continuing the conversation. So first turn the frame off, and you can see all the different steps that it took. Then turn the frame on, and all these events are being shown underneath each other. I could even continue talking. And it really helps to quickly find an issue, a debug session. This is all the different stuff that we have on the back end for voice assistants. It's time to go to the next tab. Let me share the tabs again. ESP Home. Yes.
Yes.
Shall I do this one, Mike?
Yeah. I'd say that most people are probably not going to be going into the assist panel to interact with voice. I mean, yeah, if you've done that, you've probably you could have just clicked a button, right? So
right,
something more is needed.
No, it's really just the developer features, right? Because we want to make it easier to build various voice assistants, experiment with all these features, and so we need to have good insight exactly how things work for everybody. All right, ESP Home. So some people have already noticed it because 2 weeks ago, the ESP Home release came out and it already included a new integration. But before I dive into what it exactly is, I want to just talk quickly for the people that do not know what ESP Home is. ESP Home is a software that runs on microcontrollers. Microcontrollers are very tiny computers. You can often buy them for a couple of dollars or euros. And they're very hard to program. You need to write C++. It doesn't have dynamic languages and all these kind of things. And so to make it a lot easier, we have ESP Home. It's a Nabu-Casa project. And the way it works is that you take a microcontroller. It always has different pins for interactions and input output. You say, for example, hey, I have a temperature sensor and I connect this to pin D2. You give this information to ESP Home. ESP Home will generate software, install this software on your microcontroller. This software will include your Wi-Fi credentials so that the device will connect to the Wi-Fi, and it will start publishing this temperature data into your Home Assistant installation. Now, this is great. It's been very powerful, and people can easily build their own devices for their own houses, and it's been very, very popular inside the Home Assistant community. And so today I'm very happy to announce that we're adding voice assistant support. Now, how does this look? Wrong tab. It looks like this. Don't get too scared of all the YAML. So what does it mean? ESP Home, voice assistant on ESP Home will work with push to talk. So you will need to press a button to start talking. The moment you release the button, the voice is done and it will be processed by Home Assistant. So what do you need? You'll need a microphone in your ESP home device. You'll need a new voice assistant component. And then a binary sensor input is how buttons are represented in ESP home. And so here you can say on press of the button, start the voice assistant, on release, stop the voice assistant. Now, how does that work? I'm going to show a demo right now, but before I'm going to show the demo, I actually want to talk about the demo platform that I'm using, because it's the M5 Stack Atom Echo Smart Speaker Development Kit. It's a mouthful.
Mhm.
It's a super tiny device. It's like
A literal mouthful, because you could swallow this thing.
that's true. It's really tiny. Like it's like my eye, or like I don't really know. I have like AirPods for scale, right? Like this is like half an AirPods case. This thing is super tiny, but it has a speaker, a microphone, a button. It's powered by USB-C, and it does everything that we need. And so we've been testing with this. By the way, if you're rushing to see if it's like in stock, I'm sorry to say that their official website has sold out, which is
I wonder
the
why.
worst timing ever. Like usually these things sell out after we talk about it, not before. But I know we looked around, and there's AliExpress still had a bunch of them. DigiKey had a few of them. Tiny Tronics in the Netherlands had a few of them. So you can find them, but just not on the main website. Our blog post has not been updated yet, so it will link to the one that's out of stock. So yeah, I'm going to give this demo right now. So this is the little device. I will control my frame again. Turn the frame off.
Turned off light.
So as you can see, I press the button, I speak, it processes my speech, and then there's a small speaker in here, and it was actually speaking the response to me. Turn the frame on.
Sorry, I couldn't understand that.
Turn the frame on. There you go. It's back again. Now, not only do we have this really cool device that we are using for development, we also, if people are interested in trying out the new voice assistant stuff, this is actually a very good entryway, because like it's pretty cheap, and you can actually try out speech to text, text to speech, all those things. And we actually have, to make it even easier to get started with this, Gabriella, who is a technical documentation writer at Nabu Casa, has cooked up a really cool tutorial just so that to help people go through it. So I'm gonna share this now. This will be live on the Home Assistant. This will be linked also from our blog post. It will be in the assist part of documentation. It will go through all the requirements. Of course, as you are known from us by now, to install it, you just hit the connect button. Once you've connected it, it will actually like install it directly from the website. If you don't have the drivers, it will prompt you. And you install it from the website, you configure Wi-Fi. It helps you to add it to Home Assistant also via the website. So it's a 100% browser-based tutorial. And in the end, you have a voice assistant. So really, really cool. This is coming. Also, this is now in the beta. So if you have this device, you go to this tutorial, you can already start using that today.
And you can select different pipelines, right? For the different.
Oh, yeah. Oh, man, I completely forgot that part. Let's see. Settings. I go to my ESP home device. This is my everything presence got detected, my Bluetooth proxy. So when you have this device open, what's really cool is that now, of course, there's a media player in it, so you can also just send text or speech to it without actually talking to it. There's a binary sensor called Assist in Progress. This is a binary sensor. Maybe you want, when people are talking to it, you want to have like some lights illuminated, these kind of things. And that is also possible. Let me just do a demo now so that people can see how the UI looks. Are the lights on?
Sorry, I couldn't understand.
Okay, well, you saw the color, so that's good enough. It's I said it to American English, and I think I speak American English, but I don't think speech to text always agrees with me.
I will say this thing does have a tiny little I2S microphone on it, so
that's true.
It's amazing it works at all to me.
But the other thing that's really cool is that you can change the pipeline. This is just a select entity, so you can go in and say change the pipeline. And so the ways we are envisioning this, because I'm showing you this small device, This is our development platform, our target platform, but this is ESP Home. You can build whatever you really want to build. So, for example, maybe you want to build like 2 really, really big buttons, and each button will activate, change the pipeline on the ESP Home device and then activate the voice assistant so that, for example, you have one button to speak Dutch, one button to speak Danish, one button to speak English, and you can have 3 different voice assistants. Or maybe you want to you're playing with ChatGPT and you want to talk to different characters. That's all possible by using this assist pipeline selector.
I think we had at least one question about saying, well, voice activation is really needed here at some point, and we agree. This is a push button thing, push to talk, but the plan is for the future to focus on wake word, voice activation.
Yeah, actually, that I have it. That's the next slide. That's good. No, so we are at this point we haven't talked about wake words, and we're not going to talk about wake words because wake words are very hard to do right with hardware, and we're working on it. It's a work in progress. Mike went to the Tiny Machine Learning Summit in San Francisco last month. He was even on a panel talking about this kind of technology that we're looking into. And how many vendors did you talk to? Like a lot, right?
I mean, a couple dozen. And yeah, I can't count how many times the conversation quickly shut down when I said we need the tooling to be open source, and that was the end of it, because for them they wanted it to be cloud based or their proprietary stuff where you got to sign an NDA because they want it to be a source of revenue, and that's just not something that's going to work for us. We don't want people to be able to train their own wake word in a cloud service that's going to go away in a month or even a year.
We're still mourning the loss of Snips, where Snips was this local speech to text system that was 5 years ago, 10 years ago, and it wasn't fully local, but to create and train your models, you needed to use their website. Now, at some point, they were running out of money. They got acquired by Sonos. Sonos shut them down. I mean, it became now the Sonos voice that is on their new devices. But by shutting down the Snips website, it's no longer possible to create new models. So we wouldn't want to be, making hardware, and then at some point it could be the models the chips that we put on there, we can no longer have the models for those. We cannot train them. So you're stuck with whatever we trained up to then. So yeah, we're looking into it. However, we do have one extra thing, which is, Mike, you want to take this one?
Sure. So, we were thinking about what kind of features would we want for the world's most private and coolest voice assistant. So for privacy, you want something that only listens when you're ready to talk, not all the time. When it responds for your ears only, no one else. And it'd be cool. You want something that matches your style and ideally have also a familiar interface. And it turns out such a device already exists and has been around for quite a while, even longer than me. And that is the phone. So what we've done is we've added support for voice over IP and analog phones to Home Assistant and connected it into Assist. So you can pick the coolest phone you can find in an antique shop, plug it into a box, which I'll show you here in a moment, and you can actually have a full Assist experience for not very much, actually. Just the cost of a phone in the little box. Let me share my screen since I crashed before. Here.
Yep.
All right, so I've got another little camera here to show the phone. This is actually my grandma's phone, but it has a speaker phone, so this isn't really my style. I'm in the market for a banana phone. I think that would be cool. So got the phone here. I'm going to hop over to first configure it, show you how it gets configured in Home Assistant. Before I do that, I should actually show you what it's plugged into. So this is the Grandstream. I have an HT802, but it has 2 ports, but you can get one with 1. So it's got the phone jacks, as you can see in blurry glory, and a network port. So that's really it. You just plug the phone in and plug the other side in. Then there's a web interface. You go in and you configure your Grandstream to call Home Assistant. It's called off-hook auto dial. So that means when you pick it up, it just automatically dials a number, and you just dial the Home Assistant IP with the port. And before you do that, all you got to do is come in here and add the new voice over IP integration, or VoIP. All right, so now that that's in there, then all I have to do is call Home Assistant to get started.
This is your smart home speaking. Your phone is connected, but you must configure it within Home Assistant.
All right, so you get a message.
The audio cut out a little bit, Mike. We couldn't hear it.
So it said, this is your smart home speaking. Your phone is connected, but you must configure it within Home Assistant. And if you're watching over here, a device showed up. So I can come in by default. The calls from an individual phone aren't allowed just for security reasons. So I'm going to allow calls. You can change the pipeline here as well. So just as a demo on the cloud pipeline, I can say, turn on the plant light.
Turned on light.
Turn on the LED strip.
Turned on light.
All right, so all of those things were happening, and you can see, like the debug pipeline. Let me turn off this thing; it's blinding me. You can see, like the debug pipeline, the conversation continues. So you say one thing, it responds to you. You say another thing, and it responds back to you. And so you could just pick up the phone, say what you want, and hang up when you're done. You could do some more fun things. Should I show the OpenAI?
Yeah, let's do it.
Yeah. So if you
we cannot really hear the audio, so otherwise we can also stream the YouTube video that I have.
why don't you just do that? Because if you can't really hear it,
Yeah. Yeah, it's easier said than done. No, let me. I got it.
I can. Yeah. So I set up a prompt. I installed the OpenAI integration. You set up an account with OpenAI, and it's like a few pennies for to get a couple tokens, and then just told it. I said, pretend you're Mario and be short in your answers, and that was about it.
I don't know where the demo is. Where did it go? I have it. I got it. I say actually good because I'm gonna just switch over. So right now we've been really focusing on the HT Grandstream HT801, the Grandstream HT801. That is like the way to go. We are again, Gabriella did an amazing job. We have another tutorial right on the Home Assistant website that walks through all the different instructions. We got very clear documentation, like the green one is the phone one, the blue one is the Ethernet, how to log in, how to configure it all. So it should be hopefully very straightforward to do. Again, I think Mike just showed it, but it's very important. Like you can disable calls per phone, and you can pick the pipeline. So we can really see a world where you're going to automate who's answering the phone, for example, based on some condition, or maybe every call you're going to rotate the pipeline so that you're always talking to somebody else. The other thing that before I just going to show this one, what I think is really cool is that you can just keep talking, right? Like the conversation keeps going on. And so you don't have to hang up between. You can really just, pick it up. You say something. It's instantly connected. You don't have to wait. There's not like hello, who am I speaking to? We just play a sound so you're connected and you can quickly get started. So I'm going to see if this one works. This is again with Mike's beautiful phone. The reason we use that phone in all our demos is because it has a speaker option, right? Yeah. And so we can actually hear what it's going to say. So let's hope this actually plays over screen sharing.
Hi, what is your name?
It's Amy, Mario.
Mario, how are you doing?
Wahoo! I'm doing great.
Good. And what is your favorite food?
Mamma mia. I love Amy some spaghetti and meatballs.
I see. And who would you say is your greatest enemy?
It's Bowser, the Koopa King.
I see. And where do you see yourself in 5 years?
I hope to still be saving Princess Peach and exploring new worlds.
Awesome. Thank you very much for your time.
Thank you. It's been my pleasure.
Oh, Mario. And you can pick which voice you want to, by the way. So you could match a voice to your character, and someday maybe you could train your own voice.
Yeah. So just one, for in case people are wondering how does this work, we have a OpenAI conversation integration. We launched this last time. The big change with the new release is that you can have many different times you can set it up as many times as you want, and every time you set it up, you can actually set your own prompt. So I'm gonna add some. This is the prompt, for example, I set up it was a Dutch Mario. So I was like, you're Mario, Super Mario Bros, speak Dutch, and keep the responses short, but be funny, right? And so this is like, I'll have my kids pick up the phone and like they are doing like, playing, talking to Mario, and they're like super stoked.
Yeah, my kids have been enjoying this as well and love to just say whatever. And it's a really, that's where the familiar interface right comes in, because it's so easy for them to pick up and just start talking. They don't have to. My kids have always struggled with wake words with the various voice assistants in my house, right. Especially when I was working at Mycroft. They kept saying, my son just says, "Hey, Minecraft," and it wouldn't pick up.
Yeah, no, it was actually I had it just active in my office, and my kids had just wandered in and they, picked up the phone and started talking without any instructions. So that was really good. My daughter is like 2 years old. One of the side effects, by the way, of all this stuff is that I have a huge collection of phones now. So I got this phone. It's great. Speak like this. I just got in this one also yesterday. So just to give a more classic style. Also looks great. And this is a very old one. It has like a rotary dial. Normally, it wouldn't work with void boxes like to send numbers in, but it doesn't matter because we do off-hook auto dial. So if by off-hook auto dial, it doesn't matter. The technology of like talking has stayed the same even for very old phones. And then, of course, I still have my Aerocophone. Turn off the frame. Turn off the frame.
The god of demos.
Yeah. Turn the frame off. Yes. Good.
Some people were asking, so does this work with any voice over IP phone? We've just focused on the Grandstream for now. The big for those technically inclined on this, the big limiting factor is support for the Opus codec. Because we need it for speech to text, it needs to be a bit higher than the usual phone quality audio, and Opus has support for that. And so if you have a voice over IP box that supports that, it may work just fine. If not, we'd love to get people come in and fix those sorts of things. Love for people to play around with this and to see all your cool phone setups.
Yeah. All right. Last slide. So yeah, we have phone support right now. So that only lasts us to say thank you. Thank you to everybody at Nabukasa who has been working on this for the last few months. If you want to support the work that we are doing, paying like me and Mike and all the other people that are working on all the voice stuff and all the rest of Home Assistant, rest of ESP Home, CUFDS, SigPi. A lot of it is driven by the people that work full-time on Nabukasa on this. And you can support us by subscribing to Home Assistant Cloud. So it also gives you access to high-quality text-to-speech, speech-to-text voices, end-to-end encrypted remote access, easy integration with Google and Amazon if you still need that. And you support all this amazing work. And we're going to keep going and like building cool stuff. And then thank you to all the language leaders. So this is, like we said, we have 45 languages being actively developed. Each language has a leader who kind of controls the quality and works on it. And so thank you also to all these of the people that, have been, contributing, working on it, working with other people, making sure that their language is very well supported today. and that when you use speech to text, text to speech, you actually get proper response and like it works.
And I hope next time to be also saying thank you to people for contributing voices and samples and all that. But yeah, the language leaders have really stepped up and helped us get to where we are. So we really appreciate all the hard work.
Yeah. And so once again, if you want to reach out and like contribute a voice, especially for underrepresented languages, reach out to us at voice@nabucasa.com. It will land in our inbox. So yeah, thanks everybody. And we're looking forward to see what everybody's going to do with this and how they're going to like, the cool projects you're going to build and automate in your house.
Yes. Thank you, everyone. Appreciate it.
Yo.